everybody, and welcome to our series on EasyPH. We're covering ventilation today with Shane Kinsella from MosArt. So, many thanks to Shane for running this series of webinars on EasyPH. He's given up a huge amount of his time and sharing all his learnings. So we really, really appreciate that. For anybody who doesn't know me, I'm the current chair of the Passive House Association of Ireland, and we welcome you all today. So a little bit on housekeeping. I'm going to hand over pretty quick now to Shane, who'll get started on his presentation. If you would like to ask a question, just simply type it in the chat, and then when we're going through at the end of Shane's presentation, we'll go through the questions one at a time, and we'll be able to put them to Shane at that point. We are recording the session, as have our previous sessions been recorded, and Brian will pop the link to the previous sessions up from our YouTube channel into the chat, so to make that easy for you there. Just a little reminder of our next sessions on the 29th of July. Shane will be joining us again to talk about heating and cooling, and then on the 12th of August we'll be finishing off this series with our certification process, and Yvonne will be in contact with any CPD points and certs at that point. So listen, without further ado, I'll hand over to you, Shane, and again, welcome everybody.
Thank you very much, Caroline, and welcome to everybody to the third session in our series of webinars on the EasyPH process for certifying single-family homes. So for anyone who hasn't attended either the first or second session, both of those are available now on YouTube, and you can access them. Actually, Brian has put the links in the chat there now, so they should be available for everybody to take a look afterwards. As Caroline said, we are recording these sessions. They will be available on the YouTube channel within the coming days, and they will be available for anybody to watch afterwards. So I suppose I just want to set out just clearly before we start that I suppose this is not a general PHPP webinar. This is a very specific EasyPH webinar. So we'll be sticking tightly, and I would ask anybody in the questions and answers there just to make sure the question is relevant to the EasyPH process. And I suppose there's an assumption here that anybody attending this has some understanding of PHPP. If you need more training in PHPP or anything, then this webinar might be a little bit out of what you require at this point. So we'll commence anyway. I'm not going to delay. So I'll start sharing my screen here, and we will get to work on it. Okay. So if everybody can see that there now. So I suppose we've been working with Barry McCarran's house. Barry, as everybody knows, he's the vice chair of the Passive House Association of Ireland, and we've been using his dwelling as the reference dwelling for the purposes of the webinar. So today's webinar is going to focus primarily on ventilation. So that's going to be our primary focus in this webinar. So I suppose we'll crack straight into it from carrying on from the previous webinar. So many of you will recall that we have a sheet now in EasyPH for calculating the treated floor area and the VN50, then our pressurization test volume. We also now have a sheet in EasyPH that allows us to calculate our ventilation system. So that makes, I suppose, life a lot easier for the designer in the sense that you can now quickly check your ventilation design and confirm that your ventilation design will meet the Passive House criteria. So within this tab on the EasyPH sheet, we have various inputs here. So I suppose there's various steps to carrying out the calculation. So at your design stage, you will primarily fill out this section here. This is the only bit you need to do at your design stage. So what you can do here is put in your supply flow rates in this column here. So whatever your supply flow rates are, you can load those values in. Now in this case, we've used Part F, TGD Part F values for this calculation. I suppose that's a minimum requirement in the regulations for Ireland. Anybody in other jurisdictions may have different local requirements, but we use TGD Part F here. So In this case here, the ventilation flow rates as per the design have been loaded in, and you'll see the values look a little bit strange with all the decimal point values. But what we've actually done is converted them from liters per second into meters cubed per hour. Excuse me. And we've been able then to use those values then as our design values then for demonstrating compliance with the passive house standard. So I put a little formula here. You can see the formula up the top there. In the kitchen here, we had two grills, each one delivering 6.8 liters per second of supply. And we've put in a formula there to convert it, and we've two grills then delivering an extract then of 6.5 liters per second. So to convert from liters per second to meters cubed per hour, you need to multiply by 3.6. So essentially that gives you that's the quickest way of doing it. The long way of doing it is to take your liters per second, divide them by 1,000 and multiply them by 3,600, but that's a little bit convoluted. So we just use the 3.6 factor as a quick and easy way to do the conversion. So you're required here to put in your flow rates at your maximum speed. So that's essentially your boost speed here. So in your design section, you put in the boost speed of the system that you intend to run the system at to give the flow rates. So all those various values are loaded in. You can see in this case it was 5.6 liters a second. And again, we've converted it then to meters cubed per hour. You're absolutely free to type in the meters cubed per hour to suit yourself. There's no issue there. So once you fill out all those sections there, PHPP then or EasyPH will require you up the top here then to set what your turn down speed is for your standard and boost speed. So you'll see here at the top, that's our maximum level that's given up here. So we can see the design flow rate for this dwelling was actually set at 156 meters cubed per hour. Now, in the case of Barry's dwelling, because TGD Part F actually required a higher level of general ventilation or standard ventilation, we actually set the standard and the maximum at 100% in this case. Under normal circumstances, if you had a case where you have a lower standard speed, or you have like a trickle and boost arrangement or whatever going into the house, and of course this will depend on the overall design. This is project specific rather than general advice on this one. You can actually put in your standard speed there. So under normal circumstances in passive house, we would use 77% as the wind down speed, and then we would set a basic ventilation at 54. That's not relevant in this case, and that would not actually comply with TGD Part F. So we have to run the system at 100% at all times. So based on that, then you'll see over here then that you'll see here that you've designed maximum and then you've designed standard level. So the standard level then being your trickle speed or your general speed or whatever terminology you choose to use. And you can see in this case that because we've set 100% up here, this transposing those values over at 100%. If we wind this value back here to 77, we can see that these values begin to drop to reduce proportionately, and then that allows you to carry out your commissioning on that basis. So that's some quick and easy values you can plug in there. So once you see your standard speed flow rates here, then you can then take your commissioning values. And I suppose there's a lot of misconceptions here about the measurement 1 and measurement 2. A lot of people think you have to carry out multiple measurements, but actually the idea of the measurement 1 and measurement 2 is actually that you can set all your grills and see, for a start, are the design values being met. If they're not being met, then you can recalculate them and you can fill out measurement 2 if that's appropriate. So you are actually only required to fill out measurement 1 here, and you are only required to fill that out at standard level. So if you actually find that you've got a commissioning cert handed to you by a commissioning team with commissioned at the general speed, you can take those values and just plug them straight into this sheet. There's no actual requirement to carry out multiple measurements if the values are already set. So it's more there just to, I suppose, give some flexibility if you're standing on site, with a printout with this, and you're writing in the values as you carry out the commissioning. You can actually put your first set of values in, then if you have to recommission it to get the necessary flow rate, you can fill out measurement 2. So that's what that's for. So in this case, we only filled out measurement 1 because the system had actually been pre-commissioned, and the check of the flow rates was all that was required to confirm that compliance had been met. So you can see down the bottom here that it actually calculates what the EasyPH will actually calculate automatically what the total flow rates are, just using a simple formula up the top. But as many of you will be aware, there's also a requirement in the Passive House criteria to demonstrate that you have measured the flow rate at the grill externally for showing the overall flow rate in and out of the dwelling. So you can actually plug those 2 values in up the top here then, and they can actually serve as a check measurement then to confirm that you've actually met your ventilation requirements there overall. In addition, then there's a discrepancy box then in these 2 columns that will actually check your flow rates against the design, and it will actually calculate the discrepancy on them overall, and it will show you whether how far away from the design you are. Typically, the tolerance is 10%. You must have your extract and flow rate, your total extract and total or sorry, I'll go again. You must have your total exhaust and your total fresh air flow rates must be within 10% of each other. So these checks here will actually carry out those calculations for you, and it will also show you on a grill by grill basis what your flow rates are. So any rooms that don't have a ventilation grill in them, you can just leave them blank in the design section. There's no need to fill them out. So there's nothing to put in. You don't need to type in 0 or anything like that for those. You just leave them as blank, and that will the EasyPH sheet then will carry out the rest of the calculations. So down the bottom then there's a few final little pieces of the puzzle to fill out here. So it asks you to put in what your total minimum volume level. So if you had a setback mode, say on your ventilation system, you can actually type in what that final volume is. Now, in the case of Barry's dwelling, that was a single speed, which is permitted under the Passive House criteria where it's required by regulations. So because the regulations require us to do so, then we don't need to have multiple speeds on the system. So we put in that minimum level, which is 159 meters cubed per hour here. So that value gets typed into this box here. So we also then have to confirm that we have F7 filters on the outdoor fresh air, and that we have G4 filters on the extract air. In some cases, there will be F7s put on the extract as well. So if there is F7s put on those, you can type in F7 there, if it's relevant. So some of the final things we have to do then, we have to put in the limit temperature for frost protection, okay? So we can get this value from multiple locations. In the case of the ventilation system we had here, that value was actually given to us on the Passive House certificate, and that was minus 6.4 degrees Celsius. So we need to type that value in there, and PHPP will then calculate automatically what the electricity consumption to run the frost protection system will be. Now, in reality, minus 6.4 would occur so rarely in the Irish climate that actually the likelihood of that actual frost protection system turning on is very, very low. But I suppose it's a project-specific requirement, whether you need frost protection or not on a ventilation system. There's a misconception out there that it's actually a requirement, which is not actually true. It's a requirement that a unit been forwarded for certification to PHI must have a frost protection system on it. That is absolutely set in stone. But if your climate wouldn't require you to have frost protection, due to it being very mild or something like that, the certifier can take a view on it that actually frost protection is not required, and therefore you can dispense with the need for frost protection completely in those cases. So in the context of Ireland, that typically only occurs maybe in the southern half of the country. As you get up to the northern half of the country, then you tend to have more of a requirement for frost protection. But again, that needs to be looked at on a project specific basis, and that is something to discuss with your certifier. So The last couple of things then is about silencers and things like that. If you have silencers for ventilation noise, if you have silencers on the ducts, etc., you can type in whether they exist or not. You can just put yes or no into those boxes. Again, that's a project specific situation. Generally, there would be a requirement to have some kind of noise reduction in there. I think from memory with Barry's system here, the system was actually had such a low pressure loss in it that actually the fans were able to run at quite a low speed. And I actually don't think noise was ever really going to be an issue in it. Barry can confirm himself if there's silencers, but if you do or don't have silencers, you just note that here. Again, there's not a requirement in the criteria to have silencers, except where there's an acoustic risk. So, obviously, if the unit is very noisy, you would need to go and take a look at that. So, I suppose that's the sum total of the calculation. So that's really the worst part of the ventilation process. Design process. Once you get this bit out of the way, you're actually start to get into quite a good place where it becomes much more straightforward. So we'll move on from there now down to the remaining sections then for ventilation. So uh, within EasyPH, there's a whole area, a whole section dedicated to ventilation, and there's various inputs to go into that. Thankfully, they're considerably less than going the standard road for passive house certification. So you have a couple of options here. You can select your unit directly from the list of units as normal, as we would do in a traditional PHPP, or you can actually select your unit from and fill it out into your components tab and then select it from the drop down there. It really doesn't matter which approach you take. You can also put in compact heat pumps can be loaded in here for ventilation. And there's also a possibility of loading in combined ventilation systems. We don't tend to see those much in the context of Ireland, but we do tend to see the compact system. So there's various makes and models of those out there. If you're using one of those, that's what you would select there. In this case, the Zarents and Endura Delta 450 went in to this dwelling. So we just simply select that from the drop down list. PHPP automatically pulls in the values there, and it also provides the airflow range then. So we need to check that the airflow range is suitable for the dwelling. In this case, it was 156 meters cubed per hour, so that's well within the expected range for that unit. So no concerns there. So the second thing then you have to do for your ventilation system is to load in the characteristics of the insulation on the ducting for the fresh air and exhaust. So if your unit is within the inside the thermal envelope, like most units are and should be ideally, you do have a couple of options here. You can select that the unit is in a cellar or outdoor air. In this case, it was inside the thermal envelope, so therefore we would apply it to the outdoor air and exhaust air ducts. If your unit was outside the thermal envelope, you would then have to put in the insulation characteristics for the supply and the extract ducting. So you can see here it says supply or outdoor air, extract or exhaust air. So that depends on the location of the ventilation system. So this kind of thing should be familiar to most people that are doing any modeling work for PHPP about putting in the ducting characteristics. So you simply put in the length. In this case, the length was literally the duct just comes straight up off the unit, elbows and out through the wall. So the duct run is actually very short in this case, and it was actually less than a meter, I think, from memory. We had photographs of it and stuff that proved that it was very, very short. So we can put in our duct length to suit there. We then need to put in our diameter of our duct then, which in this case was 160 mil in diameter. If you have a situation where you're using flat pack ducting for a run, say you have a long run or you have a space issue or whatever, you can you can actually convert that dimension from square to round. So what you would do in that case is you would work out the surface area of an equivalent circular duct, and you would put that surface area in whatever the diameter is for a duct like that. So you start using your pi calculation and you work out from that. So I think from memory, if you have a 220 by 90 duct, I think it works out with about 197 or something like that from memory in diameter. So you can put that value in, which will give you the correct surface area, because that's the critical thing here. The actual diameter is not that critical. It's how much surface area of duct you have for heat loss. But then you can put in your insulation thickness here. So in this case, it was a 16 mil duct that was actually made from EPS. So it was a duct, an insulated duct system by design. The final thing you have to put in then for this bit of it is to put in whether it's aluminium laminated. So essentially, that the question here is the ducting, or is the duct insulation foil backed? So a lot of the duct insulation will be foil backed. If it is, you can simply toggle on the X here as the case arises. If it's not, as was the case here, you just simply leave that box unchecked. There's nothing to put in there. And your final values then is to put your thermal conductivity in of your duct insulation. So in this case, it was 0.03 watts per meter Kelvin. It wouldn't be unusual to see those values vary from, I've seen at the lower end, maybe down as low as 0.022. At the upper end, it can be upwards of maybe 0.04 tends to be the upper end, but uh, you get the value from the manufacturer and put that value in then to represent the accurate value. So that's really all you have to do there for putting your ventilation unit in. Um, we tend to steer clients towards using certified ventilation system for their dwellings and for buildings generally. And not because there's any advantage necessarily to using a certified over a non-certified, where the big issues arise is that actually trying to get accurate heat recovery percentages and electricity consumption for non-certified units can be very, very time consuming for all concerned, for both the designer and the certifier. It also can trigger charges from PHI for carrying out the calculations, etc. So that tends to we've tended in the past to steer clients towards using certified systems. To be honest, there's so many certified systems out there now. Nearly all the major manufacturers now have certified units. So there should be no issue there sourcing a certified unit for most situations. Um, so that brings us to that bit of it. So we then move on then to kitchen hoods. So this is often a bit of a banana skin here for a lot of projects, and I suppose there's been a tendency in the past to try and use ducted extractor hoods over the cooker, and that makes sense for a lot of reasons. I suppose it takes away the particles, it can take away the heat as well, particularly in the summer months. It can also, remove a good bit of moisture and things from the air. So there's a lot of advantages there to using a ducted extractor hood. But I suppose there is one major disadvantage, which is that made that by ducting your extractor hood to outside, you're actually going to lose a lot of heat in winter, which then will actually increase your space heating demand overall for your dwelling. So we need to account for that somehow in PHPP, and I suppose EasyPH has overcome this by having some straightforward inputs, really, with some essentially a couple of questions to answer. So I suppose the first thing we have to do is see, well, what type of hood are we working with? So I suppose if we've recirculation hood, really there's very little more to do here. Only just select recirculation, and likewise, if there's no hood, there's to be done here. Inputs. If our hood, we have to get the EasyPH to work out. So I suppose the first thing we have to do is look, is the hood an efficient hood? So this applies whether it's recirculation or ducted, doesn't make any difference. And we see here that actually there's a criteria set here in EasyPH that first of all requires this to be wall mounted. So we can't use an extractor over an island or something like that, or something like that, or a free hanging extractor is not really going to cut it. It must be wall mounted. The height over it must be less than or equal to 65 centimeters or 650 millimeters. We also have a minimum and maximum flow rate requirement. So I think there might be a little error in this. It says it must be less than or equal to 250 meters cubed per hour on the minimum, but then must be less than or equal to 400 meters cubed per hour on the maximum without boost, which doesn't make a lot of sense. So I need to actually check that with PHI myself just to see is that actually correct. So it does look like there might be a little bit of an error in it, but if there's not, it would mean that you must have your minimum flow rate must be less than or equal to 250 meters cubed per hour, which is a considerable flow rate. It's about 80 liters a second, 75 liters a second, or something like that. So it's quite a hefty flow rate. At 400 meters cubed per hour, you'd have a very high flow rate out through your exhaust duct. So that's something that I say I need to just check that with PHI. I can't confirm that at this moment. But if those values are correct, then that's the criteria set there. So you select from that, or whether your HUD meets that criteria. If then you have an exhaust system or a ducted extractor system, you have two further questions here that have to be answered. So the question that's asked here is is your exhaust air opening in the building sealed during the pressurization test? So if that was sealed over, I suppose taped over or whatever on the inside or outside, then there's an adjustment has to be made to the N50 value. So if it was sealed, you tick the X in the box, and then that will apply a small penalty to your overall N50 value to reflect that. If it wasn't sealed during the test, you just leave that blank. There's nothing more to do with that. And the last question is, did you have an airtight exhaust air flap? So essentially, if you have a shut-off damper, a sealed shut-off damper on the exhaust line, you can actually switch that on there, and the requirement for that is it must be motorized or spring closing. So it can't be a manual type damper. It must be automatic opening, and usually that would be interlocked with with the cooker hood. So you switch on the cooker hood, and then the duct would the flap in the duct would open automatically. So if it's a situation where you do actually have that flap, you can actually with an exhaust system, you can actually switch that on there by again putting an X in the box there to say that you have such a system in place. So that's I suppose that brings us to the inputs for the cooker hood on that front. And then as we go down a little bit deeper now down into it, I suppose we start to look at air change rate. So this is, I suppose, where we begin now to look at our I suppose, making sure our criteria is met and things like that. So we have a requirement here to put in the commissioned, outdoor air, exhaust air volume. Um, I've put in 162 in this case. It was 159 on the fresh air, but I suppose you could put an average value in there between the two of them. So in that case, you could put in that it was equal to these two values, one divided by the other, and then sorry, you could add them together and then divided by two. So it will give you an average value on that. And what that will do is that will actually check your project against the Passive House criteria. So I suppose there's again some misconceptions out there that you must actually use the 60 meters cubed per hour, 40 meters cubed per hour for bathrooms and all that kind of stuff for calculating your ventilation rates for Passive House. That's actually not true. Those are recommended values. They're not actually criteria requirements. And there's nowhere in the criteria that actually specifies that you must use those values for your calculation. The actual criteria is based on two aspects. The first aspect is that you provide a minimum of 20 meters cubed per hour per person of supply air at all times. So that's a minimum value there. So anything in excess of that, we'll give you a yes here to confirm that that's fulfilled. The second requirement is you must demonstrate that your air change rate is more than or equal to 0.3 air changes per hour. Again, on average, so it must be above that point at all times. And from there, then EasyPH will actually carry out a check on that flow rate to confirm that actually your air change rate is being met. So you've got two yeses so far. And the last thing you've got to do, which EasyPH will do automatically as well, is it will check the difference between the outdoor air and the exhaust air flow rates, which in this case it's calculated at 2%. So we could calculate that ourselves if we wanted to check it, but the requirement, as we're all aware, is 10%. So that we must demonstrate that those values are within 10% of each other. So in this case, we have three yeses, which confirms very quickly and easily for the designer that actually you've met all the passive house criteria, and therefore you can proceed with confidence that your ventilation system is actually going to stand up to scrutiny once the certifier begins to look at it. So I think that's a very useful thing that PHI have put into the EasyPH system, that actually allows you to carry out those checks super quick there with the minimum fuss. And that's, I think that kind of changes the narrative very quickly when it comes to checking your ventilation rates. So I think that's very good overall. So I suppose as we get, towards the final piece of our webinar today, is that we have the opportunity here now to have a look at summer ventilation and to see, can we use openable windows to overcome our overheating issue. Of course, in the first instance, we should always try and demonstrate that we can meet our overheating requirements with no openable windows. And I suppose our office policy, when we're acting as a designer, in the past has always been, and still is, that we operate to 1% overheating with the windows closed at all times. And it's only as a second, I suppose, as a second point, we begin to look at openable windows and things like that. We're finding that's proven very difficult in apartments to get the overheating down. So there's a good bit of a balancing act when you're dealing with apartments, but for single family dwellings, in most cases, it should be possible to design out overheating if there's been I suppose, an effort made to avoid too much, say, west face and glazing, and there's maybe a nice bit of overshading on the south and things like that. So if the design of the building is actually suitable from an overheating point of view in the first place, you generally shouldn't have an issue with overheating. In the case of Barry's dwelling here, there was the overheating percentage with the windows closed is actually zero in the dwelling. So there's actually no concerns at all about overheating in this case. And maybe Barry might throw in a comment or two as to whether he's had any overheating issues or anything so far in the dwelling, maybe later on or do you want to jump in there, Barry, for a moment?
Yeah, Shane, just on that, we've been monitored the house from we moved in, and we're just coming up on a year's worth of actual data on this. And right, it's no surprise to me anyway, but PHPP is the monitoring versus the PHPP prediction is bang on. It's just at about 0.6%, so just below the 1%. And yeah, it's excellent. It's the most boring house ever. It's 21 degrees all the time.
Well, it's a good complaint, really, because I suppose that's the aim of the whole thing. So yeah, I suppose then again that there's further evidence there that the when an effort is made to avoid overheating, it definitely, the model can give you some reasonably accurate feedback on it, which is helpful. So I suppose if it's found that actually there is an issue with overheating, which you can check very quickly in your verification tab to see here, have you got a frequency of overheating occurring? You can actually factor in openable windows and various other things as well. So I suppose we have to start with looking at, I suppose, what are the mechanical ventilation flow rates that are used throughout the year. And I suppose the first thing it looks at is what's the mechanical ventilation rate in the heating period. So if you've got a higher value being used for the summer period, you can actually type that value in. If say you're running the ventilation system at say full tilt or something like that, you can factor in that flow rate. If not, you can just leave that blank. If it's the same, if it's the same as in the heating period, you just leave it. There's no additional inputs needed. So that input is there if you want to have a look at that. I suppose the other thing we have here then is as to whether there's a bypass system on, on the ventilation system. So you'll see there's a little note here which states there that select this if the ventilation system has heat recovery bypass that's automatically controlled. So I suppose that the key word here is automatic. If it's controlled, using temperature, humidity, which most of the systems are, they usually have either an adjustable set point or a manufacturer set point to switch on the bypass mode. Most, I think, all, if not all, certified units have a bypass mode. I think it's actually a requirement of the certification criteria. So in that case, you can actually switch on that you have an automatic bypass, that switches on and off as the need arises. So in this case, we put an X in this box. If you had no bypass, you could toggle the top box if the bypass is on for the whole summer and just stays open. In other words, if it's a manual bypass that's left open, you can toggle the lower box. So I suppose then if you're still having an issue with overheating from there, you can begin to look at optional night window ventilation. So in this case, there's various steps to completing this calculation, and I suppose you start with step one with the first input here, and if there's a no in the first step, then you don't proceed with the calculation, and that's set out quite clearly. So if you select a yes here that night ventilation is generally possible, then you've got, I suppose, a load of issues you can decide there to make that decision. You can see there's a reference there to burglary protection. I'm sure burglars are not as prevalent maybe around Monaghan as they are maybe if you're in the middle of Dublin or something like that. The likelihood of being burgled is probably considerably lower. So you have to weigh it up depending on the circumstances that you have. Also, then you have issues like traffic noise and they talk about weather protection. You can have a whole lot of other reasons you can come up with. I suppose the question here is it generally possible? And I think it would be fair to say in the context of the location of certainly a Barry's dwelling that it is possible to have night ventilation. I'm sure there's nothing, no major traffic noise or anything around exactly where he is. So in that case, you would tick yes in this box here, and then you would begin to look at the other questions below. Then, so I suppose that there's various other questions. Then actually, can this be done all around the house? So in other words, on at least two sides, have you got the opportunity to open windows? Because you might say have a dwelling where you have maybe a motorway on one side and you have nothing at the back, so you mightn't be able to open it on the motorway side, but you can at the back side or whatever. In that case, you would tick yes if that was the case here. Now I've ticked no in this case because we don't need to do it, but it is possible to have all around ventilation. There's windows in the front and back of the house is doable. The other question you're asked then is there tilted windows on the ground floor possible? So in other words, have you got tilt and turn windows that can open inwards with just a small ventilation gap in them? If that's possible, you can tick yes in that box as well. If the windows can only like open outwards or open inwards without any tilt function on them, then you have to tick no in that box as well. And I suppose that's again a project specific value there, and that only applies to the ground floor, by the way, as well. That's not for the upper floor. That is purely on the ground floor. So then I suppose the next question asks is it across stories? So if you see there's various scenarios here. If the building has at least two residential stories and the room doors can remain open at night and windows can be fully tilted, that's a lot of ands there. There's a lot of steps there before you can tick yes on that. I think in most cases, room doors will not remain open at night. That would be, I think, normal practice in most Irish homes. So I think you wouldn't expect to be ticking yes in that box under normal circumstances. And then I suppose the last question is, have you got fully openable windows? Is that possible on the upper floors? So if that's the case, you do, then you can select yes. If not, then you have to select no here. So it's again project specific. So you can weigh these up and agree them with your certifier. But if you don't have an overheating issue in the first place, then this is kind of a defunct calculation that we say if you have a major overheating issue, then you have to look a little bit more intensively at the window ventilation and see, is that a runner. So that brings us to the end of the main bit of today's webinar. So I'd hope to be finished by quarter there. So we're just a little bit ahead of time. I suppose maybe Barry or any of the other members of the PHI, would you like to try any questions before we throw it out to the floor here? You're muted out there, Caroline.
Yes, I can.
Yeah.
Barry, have you any questions or any comments that you'd like to add to what Shane has shared on your property?
Yeah, and not at all. No, there was the data on overheating, which I've shared. There also is, just relevant to that same area, the indoor air quality, Shane, and the sizing of it. And also you brought up the noise. From living in the house again for a year, we're experiencing no issues with noise. Very happy with that. The indoor air quality is excellent so far. You're talking around 500 CO2 parts per million.
Brilliant.
And then also we found that our downdraft, this might generate some discussion, our downdraft kitchen extract has been excellent so far as well. So really happy with that as well.
Very good. Yeah, no, I've heard some mixed reports about the downdraft extractors, but some people love them, other people detest the sight of them. So yeah, it's it seems that there's a lot of it certainly seems to be a controversial one, doesn't it?
It does amongst the passways community, yeah.
Yeah. Okay.
Very good.
Right.
If we might go to some of the questions
Absolutely.
from our participants, Shane. So first question in there from Tony: are the passive house ventilation rates the same as Part F for Ireland?
Yes and no on that front, Tony. I suppose the Part F flow rates are a legal requirement. So I mean, whatever happens, we have a duty here to demonstrate that there's compliance with Part F. So our experience has been that in larger single family homes, like anything over maybe 120 or 130 square meters, will actually Part F will tend to set flow rates much higher than passive house would ordinarily require anyway. So you will rarely run into any problems meeting the 0.3 air changes per hour, because typically it's more like 0.5 anyway for Part F. So Part F will generally take precedence over passive house. The exception there is in very small dwellings with maybe a kitchen, utility, and a bathroom. If the floor area was small, you might find that actually passive house requires you to put in would require additional flow rate to give you the boost rate. But under normal circumstances, Part F will always be the guiding I suppose principle for flow rates. So
very good, great. Another one in there from Tony
as well. So
Shane: is 10% of negative pressure in the house allowed?
Yes, you are. The requirement is stated quite clearly. I know Brian might want to jump in there as he's clicked on a button there, but if you choose to put a negative pressure in the house on the extract side, you are actually free to do so long as the difference between the outdoor air and exhaust air is less than or equal to 10%. You're fine. So yes is the answer there. There's no issue putting a negative pressure. We would tend not to recommend doing that unless it was required, but yeah, you can get away with it. There's no problem there.
Very good. Another question there from Tony. With uncertain climate conditions, would a preheater in Ireland be required, or should they be required?
Well, that's a good question, and this, I suppose, an issue that has arisen on a few projects. I suppose a few larger residential projects. Is there a need for a preheater? I suppose we have to look at it in the context of what's the local weather conditions going to be like. I mean, you could have the same site on top of a hill that could be a hell of a lot cooler than an equivalent site maybe on flatter ground. You can have situations where you have microclimates locally. You can have situations where I suppose the ventilation system manufacturer requires that the preheater switches on at a particular temperature. In some cases, we see temperatures maybe as low as -10 before the preheater is required to switch on. So in a situation like that, like the manufacturer is clearly happy that down to -10, the system is not going to frost up. So you might get away with it in the context generally of maybe the southern half of the country tends not to be as difficult for preheaters. But again, it's a project specific thing that needs to be discussed with your certifier. If your certifier is happy that you don't need a preheater, then the preheater can often be dispensed with, and that's been our position on a lot of projects lately, where we've actually had to say, well, a preheater is not actually required here, or actually, you know what, we're a bit of a risky side here. We would insist on a preheater in that case. So yeah, it's I think just to say there's a blanket rule of requiring it is a little unfair. Like we do get dips in the temperatures, but I suppose they occur sporadically. They occur for a couple of days every 5 years or something like that. You get a bitter cold snap. So it is very much project specific.
Okay, very good, thank you.
Okay.
Jennifer asked a question there. Are Hob integrated recirculation extractors deemed to be inefficient?
Yes, without a doubt, because they don't meet the requirement of being placed within the 65 centimeters over and are not wall mounted. So therefore, there's no question the Hob integrated extractors would always be deemed to be inefficient.
Very good, thank you, Shane.
Yeah.
And then a question from Michelle. For the opening window night ventilation, what happens if there was a mix of tilt-turn normal windows, overground and first floor? Good question.
Yeah, there was actually a mention somewhere in there. You can actually put in a partial value for that, and I'm just looking here to see just somewhere we can put in a half value for some of those values. So having a mix is absolutely fine. There's no issue there. If you need a bit more of an intricate calculation, it can be done, in within PHPP to actually see, can it be dealt with, with a bit more, I suppose, accuracy. So I suppose this approach here, it captures, I suppose, most scenarios where you need a bit more of a deeper dig. You can unhide the sheets there and have a bit more of a deeper look at it. So yeah, you can account for a mix of tilt and turn and normal windows. That's no problem.
Very good. Our fellow board member Simon has a question here.
Yeah.
Is there a requirement to submit noise data at grills in EasyPH?
There's not a specific requirement to submit noise data, so you're not actually required to have it tested and confirmed. Because it's actually, in practical terms, it's actually very difficult to get it to take the measurement on site, because you've got so many other noise sources within the room and everything. It can be actually difficult to get the value. So what the actual criteria states is that the system must be designed to deliver 25 dBA or less in bedrooms and living rooms, and then 30 dBA or less in extract rooms, then so your bathrooms and your kitchens, etc. So you won't be actually required to submit any data for certification. What you will be required to do is show that you've designed out the issue with noise in the first place. And in Barry's case, this was because the system here was running at a very low speed to actually deliver the flow rate that was required. In another case, you might do it by putting on, silencers. You might put a little bit of acoustic flex duct or something like that on the way or whatever. I suppose there's lots of ways of skinning that cap, but no, the answer here is you won't be required to submit any data for certification.
Very good, thank you. And then finally, the final question is from Tom. Why has downdraft recirculation been controversial?
Yeah, that's a great question, I suppose. They've been controversial for a number of reasons, I suppose. One of them is some people say they just don't work, in the sense that you're basically, you've got rising moisture coming up off the pot, and then you're basically relying on a fan then to suck that downwards. And some people have said they just their experience has been that they don't work. I suppose my experience has been mixed with them, in the sense I've only used them occasionally and found that they work fine in some situations. But if you've got a vast volume of steam, I found that actually they don't tend to take it away fast enough. Whereas I suppose a wall mounted extractor directly over the hob is likely to take it away much quicker. Now that doesn't mean they'll take it away perfectly, but they generally will be more effective. I suppose one of the compensation methods or one of the compensation things that's normally in a passive house is that you have the MVHR take an extract out of the kitchen anyway. So over, I suppose, the next 10 or 15 minutes after you've finished up cooking, it'll take away a lot of that excess moisture anyway over a short time. So yeah, I suppose the jury is out with I suppose in our office on them at the current time. I suppose we don't advise anyone not to put them in, but I suppose if you choose to put one in, it's your own decision ultimately. But our experience has been that overhead extractors generally are more effective.
Very good. Brilliant. Thank you very much, Shane. I suppose we will, there's no other questions there at the moment. So look, Shane, it leaves us to thank you. I'm sure our passive house practitioners online today, going through the software in such detail is a massive help to the industry. So a massive thank you to you. Again, just a reminder to everybody that we have recorded the sessions. They're online and they are on YouTube, and they will be on our website. Brian will kindly put those up later. We thank Barry for allowing his house as the case study for all of these seminars. We will back on the 29th of July for heating and cooling, and then again, as I said, on the 12th of August for certification process. Is there any final comments from anybody on the panel? Are we happy?
Yeah.
Oh. Oh, good. Listen, thank you very much, everybody, and enjoy the rest of your afternoon. Brian did pop up the link, and Brian did pop up the link there. If anybody is not a member of the association currently and would like to join us, we certainly appreciate having new members all the time. So thank you, everybody, and hopefully you'll have time to squeeze in a sandwich now or a quick run before your next meeting. Thanks, everybody. Bye-bye.
Thank you. Bye-bye.